Hello everyone, welcome to the lecture again. Now we are going to start the second part of this course, that is dynamics. In dynamics, depending upon the symmetry of the problem, we have to choose the right coordinate system. Therefore, today we are going to discuss the Cartesian and planar polar coordinates. So, we are going to discuss the coordinate systems, and the most widely used coordinate systems are orthogonal. That means that the coordinate that are involved in defining the position vector etc., they are perpendicular to each other. So, that is the meaning of orthogonal. This implies that all coordinates are mutually perpendicular. Let us first discuss what is Cartesian coordinate or rectangular coordinate. Okay. So, as all of us know, in Cartesian coordinate the axes are x axis, y axis and z axis, and the position vector of, let us say, a particle is moving, and let us say the position vector of a particle at some instant is r, and let us say this point is p. Now, along the x, y and z direction you can take the unit vector. So, you can say either I, j or k, or you can take x cap, y cap and z cap as the unit vector. So, let us say this is I, this one is j and this one is k. Therefore, when a particle is moving in the Cartesian coordinates, its position vector r can be written as xi plus yj plus zk. Let us call this equation number A or some equation. Okay. Now, in Cartesian coordinate, as you saw that x, y and z are the coordinate axes. Let us call them u1, u2 and u3. Now, when we calculate this quantity del r over del x, then let us see what we get. We get I. Okay. Similarly, when you calculate del r over del y, you get j, and when you calculate del r over del z, you get k. Also note that del r over del x, its modulus, that is the mode of I, is 1 because it is a unit vector. Similarly, del r over del y mode is also 1 and del r over del z mode is also 1. Okay. Let me call them the scale factors along x, y and z direction. So, let me call them h1, h2 and h3, and this h is just a scale factor. Okay. Now, in terms of the u1, u2, u3, h1, h2 and h3, we can write down various quantities. For example, what is the general infinitesimal displacement, what is the infinitesimal surface area and what is the infinitesimal volume element etc. Now, let me write down the general infinitesimal displacement vector dr in terms of h1, h2, h3 and u1, u2, u3. So, the general infinitesimal displacement, let us call it dr, will be h1 du1 u1 cap plus h2 du2 u2 cap plus h3 du3 u3 cap. Okay. I am not proving this formula, but we will use this formula in various coordinate systems. So, here h1, h2 and h3 is 1 1 1, u1, u2, u3 are x, y, z. So, therefore, dr vector will be 1 dx and x cap or I cap plus h2 is 1 dy j cap plus 1 dz and k cap. Therefore, dr is dx I cap plus dy j cap plus dz k cap, and this is something that we already know. Now, let me write down the infinitesimal surface area in terms of h1, h2, h3. Let us say it is ds. So, ds will be h1 du1 h2 du2, okay, and its direction will be perpendicular to u1 and u2. So, it will be in u3 cap direction. Let us see, ds will be h1 and h2 is 1 and du1 du2 is dx and dy, okay, and its direction will be perpendicular to xy because we are calculating the area in xy. Therefore, it will be in z cap direction. I am not writing down the direction here, ds will be dx dy, and again this is something that we already know. Now, let me write down infinitesimal volume element dv in terms of h1, h2, h3. So, dv will be h1, h2, h3, du1, du2, du3. Okay. So, in Cartesian coordinate dv will be 1, 1, 1, dx, dy, dz, and therefore, dv will be dx, dy, dz, and we already know again that the volume element in Cartesian coordinate is dx, dy, dz. Now, let us look at very important point. In Cartesian coordinate, let us say the particle is moving and at some instant it is at this point, let us say it is some x1, y1, z1, and after some time it is at other point, let us say x2, y2 and z2. Then look at the unit vectors. So, here the unit vectors are I, j and k, and when it goes to different point, then again the unit vectors are I, j and k. This tells us that the unit vectors does not change direction from point to point. So, when the particle moves from one point to other points, the unit vector they do not change direction in Cartesian coordinate. So, let us look at equation number A again, which is position vector r. In Cartesian coordinate it was xi plus yj plus zk. Therefore, the velocity or r dot will be x dot I plus y dot j plus z dot k. Note that because I, j and k they do not change, therefore, they are constant and we do not need to take their differentiation. Okay. Now, let me write down the acceleration A, which is r double dot, it will be x double dot I plus y double dot j plus z double dot k. Okay. Now, let me emphasize that the expression of velocity and acceleration is quite simple in Cartesian coordinate, because the unit vectors do not change when the particle or object move from one point to other. Let us now look at planar polar coordinates. Let us say we have x axis, y axis, and a particle is moving. Let us say it is at some point x1, y1, and later it is at some point x2, y2. In polar coordinate, the position of the particle is denoted by r and theta. So, let us say the position vector is r and it is making an angle theta from the x axis. Therefore, the unit vectors along the r and theta will be r cap and perpendicular to it will be theta cap. Now, when the particle moves from, let us say, x1 y1 to some other point x2 y2, then you can see that the direction of r cap and the direction of theta cap has changed. So, let me write it. The unit vectors changes direction from point to point for planar coordinate system. Okay. Here planar means the body is moving in a plane. Okay. Now, let me write down vector r. So, vector r is its magnitude and the unit vector along r. Let me call it equation number 1. Now, from the figure you can write down vector r in terms of magnitude r and theta. So, it will be r cos theta I plus r sin theta j. This is from the figure. Now, let me again calculate what is del r over del r. Okay. Earlier, note that we calculated del r over del x, where x was the coordinate axis. So, here the coordinates are r and theta. So, let us calculate del r over del r, and we expect it to be a unit vector along r. So, it is cos theta I plus sin theta j, and it should be a unit vector. Therefore, del r over del r should be equal to 1. Let us check that. Square root cos square theta plus sin square theta, this is equal to 1. Therefore, we have unit vector r cap equal to cos theta I plus sin theta j, and this will be our h1. Now, let us calculate del r over del theta. Okay. So, del r over del theta should be a unit vector along theta. So, let us see that minus r sin theta I plus r cos theta j, and we can take r as a common factor. So, it is minus sin theta I plus cos theta j. Okay. Now, del r over del theta mode should be 1, but it comes out to be r sin square theta plus cos square theta. Therefore, it is r, it is not 1. So, let us call this h2, and then the unit vector becomes theta cap equal to this minus sin theta I plus cos theta j. Let me call this equation as equation number 2 and this equation as equation number 3. So, now we got the unit vector in terms of I and j, which are the unit vector in the Cartesian coordinate. You can check that the magnitude of r cap, as I said, it is 1, and the magnitude of theta cap is also 1. Okay. Now let us see whether r and theta are orthogonal or not. So for that we have to take the dot product of r cap and theta cap. So let us take r cap dot theta cap, and r cap from equation number 2 is cos theta I plus sin theta j. So it is cos theta I plus sin theta j, and dot product with theta cap which is minus sin theta I plus cos theta j minus sin theta I plus cos theta j, and it comes out to be minus sin theta cos theta plus sin theta cos theta, which is indeed 0. So that means that r cap is perpendicular to theta cap. Now we are going to find out the expression for the velocity and acceleration in planar polar coordinate system, but for that we have to first find out how r cap and theta cap changes with time. So therefore let us find out what is dr cap over dt. This will be d over dt, r cap, and r cap is here. So it is cos theta I plus sin theta j, and it will be minus sin theta, then derivative of theta is theta dot I plus cos theta, theta dot j, and I can take theta dot outside. So it is minus sin theta I plus cos theta j, and minus sin theta I plus cos theta j is nothing but theta cap. So you can look at equation number 3, theta cap is minus sin theta I plus cos theta j, therefore this becomes theta dot theta cap. Now let us also see what is d theta cap over dt. So it will be d over dt, theta cap is minus sin theta I plus cos theta j, this becomes minus cos theta theta dot I minus sin theta theta dot j, and I can take theta dot common. So it is minus cos theta I minus sin theta j, and it is minus theta dot, this becomes r cap. Let us call it equation number 5. Now let us find out the expression for velocity and acceleration in polar coordinate system. So we have equation number 1 wherein we wrote vector r equal to r cap. This was our equation number 1, remember, this was our starting point. Therefore r dot, which is velocity, dr over dt, it will be d over dt r cap, and this will be r dr cap over dt plus r cap, and the derivative of r is r dot. Now we already know the expression of dr cap over dt, this is something that we have calculated in equation number 4. Therefore it will be r dot r cap, this is this term, plus r dr cap over dt is theta dot theta cap. This is the expression for the velocity in this coordinate. Okay. Here the first term is along r cap. So therefore the radial velocity Vr is r dot, and the velocity along theta cap is called the angular velocity V theta, this is r theta dot. And if you want to find out what is the total velocity, then total velocity will be Vr square plus V theta square. Now let us find out the expression for the acceleration, r double dot, which is a, which is d over dt of r dot, and r dot we already have. This is your r dot. So, r dot r cap plus r theta dot theta cap. Let us find out this derivative. So, it is first function as it is, then d r cap over dt plus r cap r double dot plus, let us say this is the first function. So, we have r theta dot d theta cap over dt plus theta cap r theta double dot plus theta dot r dot, and now we know what is this function and what is this function, because d r cap over dt and d theta cap over dt we have already calculated in equation number 4 and 5. Let us put this in this equation. So, we have r dot, this is theta dot theta cap plus r double dot r cap minus r theta dot square r cap plus theta cap r theta double dot plus theta dot r dot. Let us collect the terms of r cap and theta cap. So, we have r double dot minus r theta dot square r cap plus r theta double dot plus 2 r dot theta cap. This is the expression for the acceleration. This term is along r, therefore, it is called the radial acceleration, and let us denote it by AR. So, AR is r double dot minus r theta dot square, and this term is angular acceleration. Let us denote it by A theta. So, A theta is r theta double dot plus 2 r dot theta dot, and if you want to calculate the total acceleration, its magnitude, so it will be A r square plus A theta square. Now, let us analyze the expression of velocity and acceleration for circular motion. So, for circular motion r is constant, okay. Therefore, r dot and r double dot will be 0. Now, let us look at the velocity. Velocity was r dot r cap plus r theta dot theta cap, but r dot will be 0. Therefore, Vr is 0 and V theta is r theta dot, and theta dot is nothing but omega. So, we know that V equal to r omega for circular motion. Now, let us look at acceleration A. Acceleration A is, let us look at this expression. Here r dot will be 0. So, you have minus r theta dot square r cap plus this term will be 0. So, you will have r theta double dot theta cap. Here this term is called the centripetal acceleration, and it is r theta dot is nothing but omega. So, it is r omega square, and the minus sign that you see, it is because this acceleration is towards the origin. Okay. Now, let us come back to the planar polar coordinate system and derive the expression of infinitesimal displacement vector dr, surface area ds. So, dr will be d r r cap, and it will be first function as it is, differentiation of the second one, plus second function as it is, differentiation of the first one, and this becomes r d theta theta cap plus r cap dr, or I can rewrite it as dr r cap plus r d theta theta cap. Also, you can find out this using the expression of h1 and u1. Remember, dr was h1, du1 u1 cap plus H2 du2 u2 cap. Since it is planar, so there is no H3. So we have H1 is equal to 1, du1 is r, so dr r cap plus H2. Remember H2 was r, so therefore it will be r, du2 is d theta and then theta cap. So we have dr equal to dr r cap plus r d theta theta cap. Okay. Now let me write down the expression for the area. Remember it was H1 du1, H2 du2 and H1 is 1, du1 is dr, H2 is r and du2 is d theta. Therefore this becomes r dr d theta. This is something that you already know. Now for the volume, since it is planar motion, therefore there is no volume. With this, let me stop here. See you in the next class. Thank you.